If sine x equals 2 divided by 3, and x is greater than or equal to pi on 2 and less than or equal to pi, find the value of cos of x and tan of x. So before we get into this problem too far, let's have a look at the domain for this. So we have x is between pi on 2 and pi, and that places our angle into the second quadrant. So if we think about the quadrants of the unit circle, we know that it goes cosine is positive, all are positive, sine is positive, or just tan is positive, so that's cast. So we're expecting in the second quadrant, which is this quadrant here, sine is positive, but cosine is negative, and so is tangent. So we know that our final answer must be negative for both of these values. So now we can go into finding the value of cos of x and tan of x. And to do this, we've got the ratio of the opposite and the hypotenuse. And that's because we know that sine of an angle theta is that ratio of the opposite and the hypotenuse. So with that in mind, we can construct this right-angled triangle, where this is our angle x, our hypotenuse is 3, and our opposite is 2. So that comes from the 3 and the 2 back up here. And now we can use Pythagoras' theorem to find the unknown length. So Pythagoras' theorem tells us that h squared is equal to a squared plus b squared, where this value here is h, this might be b, and this value here that we're looking for is a. So therefore, 3 squared is equal to a squared, our unknown, plus b squared, which is 2 squared. Therefore, 9 is equal to a squared plus 4, giving us a squared is equal to 5, and a is equal to the square root of 5. So that's that value here. So now that we've got the side lengths of this right-angled triangle, we can easily find cosine of x and tangent of x. So the ratio cos of x is equal to the adjacent side length over the hypotenuse. Therefore, cosine of x is equal to, and we need to remember that it's negative, the adjacent value is root 5 over the hypotenuse, which is 3. So that's the cosine of x value. For part B, we know that tangent of x is the ratio of opposite over adjacent, so that's TOA. Therefore, tan of x for this right-angled triangle is equal to the opposite, which is 2, divided by the adjacent, which is the square root of 5. And keeping in mind that this needs to be negative because of the quadrant that we're in. Just before we finish up, if we did want to rationalize the denominator, we'd multiply by the square root of 5 over the square root of 5. And that would give us as our answer negative 2 root 5 over 5. And that would be the value of tangent of x.